Hello my dear students, today we will have the second revision. So starts with question number 12. The economic uses of the oxides of the transition metals are diverse. Which of the following choices is correct? So we have to say the use and the oxidation state of the metal. If both correct, then it is correct. Choice A, used in cosmetics. Used in cosmetics is zinc oxide or titanium dioxide. Titanium dioxide, the oxidation state of titanium is positive 4. Zinc oxide is positive 2. So this is not correct. B, used in dry cell. What is used in dry cell is manganese dioxide. Its color is brown to black. Its oxidation state is positive 4, not positive 3. So both are not correct, A and B. A catalyst in the decomposition of hydrogen peroxide, it is manganese dioxide, and the oxidation state of manganese here is positive 4. So this is the correct answer. It is a compound used as a catalyst, which is in the decomposition reaction of hydrogen peroxide. It is manganese dioxide, and the oxidation state of manganese in this oxide is positive 4. So this is the correct answer. Among the famous manganese compounds are manganese dioxide, potassium permanganate, and manganese sulfate. Which of the following choices is correct for these compounds? Okay, manganese dioxide, manganese oxidation number is positive 2, so this is not correct. We know all that the whole molecule is neutral, and each one oxygen atom carry a charge of negative 2, so negative 2 multiplied by 2 equals negative 4. So manganese here is positive 4, not positive 2. Yes, manganese dioxide used to reduce sulfuric acid. No, it is not correct. Manganese dioxide is an oxidizing agent, strong oxidizing agent in dry cell and in the decomposition reaction of hydrogen peroxide. It is not used to reduce sulfuric acid. So reacts with aluminum, forming aluminum oxide and manganese. So this is not of the reactions of manganese dioxide. Manganese oxidation state number or oxidation number is positive 4. Yes, it is positive 4 here. So this is the correct answer. Let's check the other choices. Okay, manganese here, potassium permanganate used in purification of water. Yes, it is correct. Manganese oxidation state is positive 7. It is correct. Yes, positive 1 here on the potassium, and negative 8 in oxygen, and positive 1. The subtraction between the two is positive 7, which is the oxidation state of manganese. Okay, oxidation state of manganese in potassium permanganate equals positive 7. You have to memorize it. Okay, it is used in detecting of malignant tumor. No, it is not correct. Used in fish tanks as antiparasitic. Yes, it is an oxidizing agent. Potassium permanganate is an oxidizing agent. Also, it is used as fungicide, antiseptic. So it is correct here. Manganese sulfate, one of the manganese alloys. No, it is a compound. It is not alloy. Used as ink dryer. It is not correct. Manganese oxidation number is positive 2. Yes, manganese oxidation number here is positive 2 as sulfate negative 2, and manganese positive 2 as the whole molecule is neutral. So it is correct. Adding to the soil to protect citrus crops. Yes, it has a fungicide effect like copper sulfate. Manganese sulfate also has a fungicide effect. So it is used to protect citrus crops. It is added to the soil as a fungicidal. Okay, so the correct answer here is D. Manganese dioxide, its oxidation number, manganese oxidation number in this compound is positive 4. Potassium permanganate is used in fish tanks as antiparasitic. It is an oxidizing agent and antiseptic agent. Okay, manganese sulfate is added to the soil to protect citrus crops as it is a fungicide like copper sulfate. Let's have another example, another question. This battery opposite here operates, so the battery shown in the opposite figure is rechargeable, and during the operation these two reactions take place at its two electrodes. Okay, here X is oxidized into positive X to positive 2. Here Y, its oxidation state is negative 2 plus negative 1. It is positive 3 here, as the whole molecule is neutral, so it is reduced here to positive 2, as each hydroxyl group carry negative 1, negative 2 here, positive 2 on Y, so it is reduced from positive 3 here to positive 2. So what is the question? What are the two elements X and Y respectively? X here, it may be scandium. Look at this. Scandium cannot have the oxidation state positive 2, so it is not choice A. Hydrogen, is its only oxidation state is positive 1, except that in active metal hydrides it is negative 1. It is not at all positive 2, so hydrogen cannot be the X. Cadmium here is oxidized from elemental state 0 to positive 2 here, so it may be cadmium. Nickel, the oxidation state of nickel can be 3 and can be 2. Yes, it can be the correct answer. Mercury can be oxidized from elemental state 0 to positive 2 in its hydroxide. Zinc, its only oxidation state is positive 2, as we have taken, so it cannot be oxidized nor reduced from one oxidation state positive to another positive oxidation state. Okay, so it is not correct. So the correct answer here is C, cadmium and nickel. Cadmium can be oxidized from elemental state to positive 2. Nickel has 3 oxidation state, positive 2 like this, and positive 3 and positive 4. So it is cadmium and nickel, and the choice is C. Which of the following electronic configurations represent a main transition element? Main transition element, by definition, they are the elements which contain electrons in the d sublevel, not completely occupied, contains but not completely filling the sublevel D. So if it is completely filling the D, it is not correct. If there is no D at all like this, it is not correct. Okay, so here D sublevel is completely filled. D sublevel is completely filled. By definition, they are the elements which contain electrons in the D sublevel but not completely filled. So C and D are excluded. Here there is no D at all. There is no D sublevel. So here 3s2, 3b6, 3d2 and 4s2. So 3d2 is filled but not completely filled. It is occupied. 3d is occupied with electrons but not completely filled. This is the electronic configuration of titanium, and B here is the correct answer. Okay, another example. The number of electrons of the sublevel D in iron 2 ion does not equal the number of electrons of the sublevel S, of the sublevel or sublevels in these choices. Okay, here by looking at the iron 26, 4s2 and 3d6, so the number of electrons in the D sublevel here equals 6 electrons. It can be contained in the B sublevel of neon 10, 1s2, 2s2, 2b6, so it is contained here. D sublevel of iron atom 26 as its atomic number, so the electron distribution is argon 4s2 and 3d6. So 3d6 here, 3d contains 6 electrons here. B in chloride ion, not chlorine. Chloride ion contains 18 electrons, like the electron configuration of argon. So it is 1s2, 2s2, 2p6, 3s2 and 3p6 also. So the electrons in B here is 6 electrons, like the number of electrons here in the D sublevel. But here, without any calculations, S, the maximum electron that can satisfy the S in any element, is only 2 electrons. The sublevel S contains one orbital satisfied with 2 electrons. So 2 electrons is not equal to the 6 electrons in the D sublevel of ion. Okay, so the correct answer here is B. Let's have another example. Let's have another question. In terms of the opposite figure, all the following are correct except, so we will choose the wrong answer. Okay, so all the typical transition elements in the first transition series form oxidation state positive 3. Here in this figure, oxidation states and elements from scandium to zinc. We all know that the zinc is not a typical transition element. It is from group 2b, and its only oxidation state is positive 2, and in its elemental state, and the only oxidation state positive 2, the D sublevel is completely filled with electrons. So by the definition, it is not from a typical transition element. So all the typical transition elements from scandium to copper have the oxidation state positive 3. So all the typical transition elements in the first transition series can form oxidation state positive 3. It is correct. So we will choose the wrong answer. So we will not choose this choice. So B, all the metals of the first transition series have the oxidation state 0. The elemental state of each metal, and it is found in nature, by the way, is 0. So it is correct for all elements in the periodic table. So we will not choose this as it is one of the correct answers, the correct choices. We will choose the exception, which is wrong. One of the oxidation states of iron indicates losing or loss of 3 electrons from the 3d sublevel. It is not correct. The only oxidation state of iron is elemental state 0, positive 2 ferrous, and positive 3, which is ferric, and it refers to ferrous refers to the losing of 2 electrons at the 4s, and positive 3 refers to losing 2 electrons from the 4s and 1 electron from the 3d. If the ion of iron loses 3 electrons from the 3d in addition to 2 electrons from the 4s, its oxidation state is positive 5, and it is not one of the oxidation states of iron. The only oxidation states of iron is positive 2 and positive 3. Look at this. Here, iron 26, 4s2 and 3d6. If it loses 3 electrons from here, from the 3d, then it must lose before that 2 electrons from 4s and 3 electrons from the 6 electrons of the 3d. So its oxidation state here is positive 5, and it is not one of the oxidation states of iron. So here it is not the correct answer. It is a wrong answer, so it is the exception here. So we have to use one of the oxidation states of iron indicates the loss of 3 electrons from the 3d sublevel. It is not correct, and it is the choice that we must choose. Another question: the oxidation state of the first transition series elements range between it ranges between positive 1 in copper cuprous to positive 7 in manganese. So this is the correct answer. Okay, the correct answer here, the oxidation state of the first transition series ranges between positive 1 in copper and positive 7 in manganese. Let's have another question. The following compounds can act as oxidizing or reducing agents in the chemical reactions except. Okay, here the main idea is that the oxidation state of the ion or the metal can be oxidized means can lose more electrons, or can be reduced, can acquire electrons. So it is a middle state between two oxidation states of the metal. So if this metal has two oxidation states, one higher and one lower than the oxidation state of these metals, or in these compounds, then this is the correct answer. Here ferrous can be oxidized to ferric and can be reduced to iron, so it is correct to use it as an oxidizing or reducing agent. Manganese here, manganese oxide or manganese to oxide, its oxidation state is positive 2. We all know that manganese can be reduced to manganese in elemental state, which is 0, and can be oxidized to manganese 3 and manganese 4 and manganese 6 and manganese 7. So here can be oxidized and reduced. Scandium here has only one oxidation state, positive 3, can be reduced to scandium 0, elemental scandium, cannot be oxidized more than positive 3. So this is the correct answer. It can be used as an oxidizing agent. It can be used as a reducing agent. It cannot be oxidized. Okay. Here chromium has this oxidation state is positive 3 of chromium, so it can be oxidized into positive 6 and can be reduced to elemental chromium, or can be reduced to chromium positive 2, as we all know that positive 2 oxidation state is a common oxidation state for the first transition series. Here scandium cannot be oxidized more than positive 3. The oxidation state here, oxidation number of scandium here is positive 3. It cannot be oxidized to positive 4 or positive 5. So cannot be oxidized and cannot be and can be reduced. So it can be an oxidizing agent, but it can be used as a reducing agent. So this is the correct answer here. By the way, all these has multiple oxidation state except scandium. Iron has multiple oxidation state, manganese multiple oxidation state, chromium multiple oxidation states, scandium has only one oxidation state, which is positive 3. So it cannot be oxidized more than this. It cannot be used as a reducing agent. So let's have another example. What is the oxidation state which common among the transition metals in the fourth period in the periodic table? The common oxidation state, it is known that it is positive 2. The common oxidation state for the first transition series is positive 2. Although that scandium has only one oxidation state, but we all know that other elements have the common oxidation state positive 2, from titanium to copper. Okay, so it is the common oxidation state in the first transition series elements, it is positive 2. In which of the following oxides is manganese ion most stable? Most stable means 3d sublevel contains 5 electrons, have filled. So here it is 4. Look at this. Manganese here 25, argon for S2 and 3d5. So if it loses only 2 electrons and has the oxidation status of positive 2, then it is the most oxidation state, as the 3d sublevel is have filled more stable. Here the manganese positive 4, it is not the most stable state. Here it is positive 4. Okay, here positive 3. Manganese here is positive 3. Manganese here is positive 2, and as the 3d sublevel is half filled with electrons, so it is the most stable state of manganese. Which of the following pairs of elements can have more than one oxidation state in their compounds? Chromium, positive 2, positive 3, and positive 6, and there is some not common oxidation state, but in general the common oxidation state is positive 2, positive 3, and positive 6. multiple oxidation states. Zinc is only one oxidation state. So the question here is about the two sets of metals, of elements, has or have multiple oxidation states. So zinc here has not more oxidation state, it has only positive 2 oxidation state. Copper here positive 1 and positive 2, scandium positive 3, only oxidation state of scandium, so it is not correct. Here manganese ranges from positive 2 to positive 7, titanium positive 2 and positive 3 and positive 4, so manganese and titanium correct, they have multiple oxidation state. Here this choice is not correct, as zinc has only one oxidation state, which is positive 2, so the correct answer here is manganese and titanium. So what is the metal whose the most common oxide has the chemical formula of MO3? So the oxidation state here of M is positive 6, as the whole molecule is neutral and each one oxygen ion contains or carries negative 2. Negative 2 by 3 equals negative 6, and the whole molecule is neutral, so M here, its oxidation state is positive 6. So positive 6 here in group 6b, it is chromium 4s1 and 3d5. It loses all the electrons of the 4s, the 1 electron of the 4s and 5 electrons from the 3d, so it is chromium here in group 6b. Its common oxidation state is positive 6. Okay, the ion which have the electron configuration 3d6. Okay, manganese positive 2, manganese 25, 4s2 and 3d5, loses 2 electrons from the 4s, so the 3d contains 5 electrons, so this choice is not correct. Ferric, it is the most stable state of iron, as the 3d sublevel is half filled with electrons, contains 5 electrons, so it does not contain 6 electrons in the 3d. Chromium positive 2, chromium from group 6b, so its abnormal configuration, electron configuration, is 4s1 and 3d5. So when it is positive 2, it loses 1 electron from the 4s and 1 and another electron from the 3d, and it contains 3d4, so it is not correct. Here iron and cobalt, iron positive 2 and cobalt positive 3. Iron 4s2 and 3d6, it loses 2 electrons and there remains 6 electrons in the 3d, so it is correct. Cobalt here 4s2 and 3d7, 27 here, so cobalt positive 3, it loses 2 electrons from the 4s and 1 electron from the 3d, and the remaining electrons is 6 electrons, so here the correct answer is ferrous and cobalt 3. They are both of them contain 6 electrons in the 3d sublevel. Okay, let's have another question. Which of the following represents the correct descending graduation of stability of the aqueous solution of the following ions? So here the main idea is that ferric and manganese positive 2 is more stable than all these elements or ions, as they contain 3d half filled, contains only 5 electrons, so it is most stable. Here manganese is highly stable than ferrous, so it is not correct. Manganese here is higher in stability than cobalt, as cobalt positive 2 contains 7 electrons, so manganese here contains 5 electrons half filled, so it is not correct. Here manganese contains in 3d 5 electrons. Chromium contains 4 electrons, chromium positive 2. Chromium 4s1 and 3d5 loses 2 electrons, 1 of the 4s and 1 from the 5 electrons of the 3d, so 3d contains 4 electrons, so the more stable is manganese positive 2. Here manganese positive 2, so this is not correct. Here manganese positive 2, 3d5, iron positive 2, 3d6, so it is more stable. Manganese here is more stable than iron, than chromium, as it contains 4 electrons, it needs 1 electron to complete the half filling of the 3D, and cobalt here contains cobalt positive 2, 7 electrons, so it is not half filled, so this is the correct answer. Okay, let's have another example. What is the number of unpaired electrons in cobalt ion 2? Cobalt 27. Cobalt 27. So its electron configuration is 4s2 and 3d7. 3d7 here, look at this. Cobalt 3d7. Okay. 1, 2, 3, 4, 5, 6, and the 7th electron filling this orbital. So there is still 3 unpaired electrons, okay, in the cobalt ion. After cobalt positive 2, so after it loses 2 electrons from the 4s, there is still 7 electrons, and it is correct also for the elemental state and the positive 2 oxidation state of cobalt. So here it is 3 unpaired electrons of cobalt ion 2. So the number of unpaired electrons here is 3. At this point we finish our session. Thank you.